Hi guys, so picking up where we left off, this example, whenever we have 25 milliliters of a 0.05 molar barium hydroxide solution with 40 milliliters of a 0.051 molar nitric acid solution. So here we have a strong base and a strong acid. So remember, acid and base, they're going to neutralize the number of moles. So we have to figure out moles of both to start with. So for barium hydroxide, remember we are doing the molarity, so the 0.050 molar. And because there are two hydroxides, we do have to multiply that by 2. That's going to be multiplied by the 25 milliliters, so 0.025 liters. That is going to give us 0.0025 moles of hydroxide ions. And then we need to do the same thing for the nitrous acid, the HNO3. Its molarity is the 0.051 molar multiplied by the 40 milliliters, so 0.040 liters. So we have 0.00204 moles of hydrogen ions. So remember, we have to subtract these to see what cancels and what is left over. So if we do the 0.0025 minus 0.00204, that means that we have 0.000, basically 0.0005 moles of hydroxide left over if we did sig figs all the way through. Divide that by our total volume. So 25 milliliters and 40 milliliters is 65 milliliters, so 0.065 liters. So that means that we have 0.0077 molar hydroxide ions that are left over. We can plug that into POH. So we get that our POH is 2.11. And then our pH, when we subtract from 14, is going to be 11.89. So note that since we had excess hydroxide, this is going to be a basic solution. So that pH should be greater than 7. All right, let's do one more example. So this one, it says we have 50 milliliters of a 0.01 molar nitrous acid is added to 25 milliliters of a 0.025 molar hydrocyanic acid. So one thing to note is nitrous acid, remember, is a strong acid, whereas the hydrocyanic acid is not strong, so it is weak. So whenever we are finding moles, we're going to have to treat the weak acid differently. Remember, we have to use the Ka and look at how much of it ionizes. So I'm going to deal with the hydrocyanic acid first. So HCN, remember, whenever it is added to water, is going to be an equilibrium system producing the hydronium ion and the cyanide ion. Remember, hydronium is basically the same thing as hydrogen. For our ice table, we're starting with a 0.025 molar hydrocyanic acid, none of our ions. So we're going to have to increase by a factor of X on our product side, decrease by a factor of X on our reactant side. And if we look at the Ka value for hydrocyanic acid, is 4.9 times 10 to the negative 10th. So wherever we plug that in, we end up with the X squared, where we combine the X times X divided by, we can ignore X in our hydrocyanic acids, the 0.025. So we can figure out that that X is going to be equal to 3.5 times 10 to the negative 6. That is going to be our molarity for our hydrocyanic acid, our HCN. So now that we have the molarity of our hydronium, we can figure out moles of hydronium or moles of hydrogen. So for hydrocyanic acid, we're taking that 3.5 times 10 to the negative 6 molarity, multiply by the volume of 25 milliliters, so 0.025 liters. And we get that this is a total of 8.75 times 10 to the negative 8 moles of the hydrogen ion or hydronium ion. Whenever we look at the nitrous acid, since it's strong, remember the concentration of the hydrogen ions is equal to the concentration of the acid. So our molarity is 0.010 molar, multiplied by the 50 milliliters, the 0.050 liters. That tells us that we have 5.0 times 10 to the negative 4th moles of hydrogen. So remember, since these are both acids, we do need to add them together. So if we add them together, that is equivalent to 5.0 times 10 to the negative 4th molar whenever we look at our steak figs. Divide that by our total volume, which is 75 milliliters, so 0.075 liters. We get that that's a molarity of 0.0067 molar hydrogen ion, which when we plug into pH is going to be equal to 2.18. Now, if you notice, the molarity of hydrogen or the number of moles of hydrogen did not change when you added them together. So whenever you have a strong acid and a weak acid, you are always going to base the pH off of the strong acid or strong base whenever you are combining a strong and a weak. So hopefully this helps. Definitely try some of the practice problems that are noted and pay attention to, are you dealing with strong acids and bases, weak acids and bases, or do you have a mixture of them?